Right, yeah, so I'll talk about taking cloud native offline. I think what I'm going to talk about is not just inherent to cloud natives, and so hopefully it will lean into other bits of your business and stuff like that that you can take offline too. One thing I probably should thank the organisers for is this therapy session they've given me, where I can just vent all my frustrations over the years. Hopefully it'll be constructive criticism, but if not, tough. So yeah, I'll just be kind of focusing on some of the stuff that has annoyed me on both sides of the vendor barrier. So I've worked for defence companies deploying stuff, and then I've been a vendor on the other side trying to sell stuff to banks and big pharma and stuff like that as well. So Amazon did a little demo for me yesterday of why you might want to consider some of this stuff. And then we've had the NPM attacks as well recently, and a few other things as well. So there's quite a lot of reasons why you might be wanting to do this. I'm going to focus more on who I am, what are the problems that I've seen, what are the problems you get with air-gapped networks, with isolating things, decoupling, not just isolating, but removing your dependencies. How might we solve them? Some examples, mostly terrible, of how I've solved them, but also hopefully a demo of a couple of tools if we get time to that point as well. I hope I'm not going to get sidetracked too much into anecdotes about my life, but please come find me afterwards. I've got lots of examples of everything I talk about that I can probably better share in a non-recorded fashion. So yeah, feel free to ask questions as well during the talk. So, who am I? I'm Patrick Stevens. I have spent 23 years now as a professional software engineer. A large portion of that time, initially 15 years, I spent doing defense. We provided platform as a service to all the platforms in that sense, ships, submarines, helicopters, stuff like that were deployed by UK, France and Australia. I then moved to working at a database company, and then I moved to a very small startup that got acquired by a larger startup in the observability space. So I've been on both sides of the kind of, I want to use offline things and I want to sell you offline things argument. I'm also a core maintainer for FluentBit, so if anyone wants to talk about that as well, come find me too as well. And I run an open source consultancy around supporting FluentBit for enterprise as well. So, what problems do we have with offline isolation, those kind of problems that you want to see in your business? So, I'm going to be talking about taking cloud native offline, but focusing on that as a kind of a spectrum. There's people like submarines who run a Faraday cage underwater for 6-9 months at a time, and then there's people who just want to decouple themselves from the latest AWS incident. Maybe not just pull things straight off the internet, but at least have a way of mirroring, failing over, those kind of things. And there's a big spectrum in between as well. You've got banks, financial service institutions, you've got a lot of people who want to protect IP, and maybe they just want to run more isolated networks and limit the blast radius of those networks as well. You've got problems with security as well. So what do you mean by security? Build time, supply chain security with the NPM attacks. Runtime, do you want to check if someone's in your system? Do you want to check what it's doing? How's it working? You've also got problems with compliance and data security. So a lot of the use cases I've worked on from the selling to customers side has been more around compliance. You've got federal institutions, you've got financial institutions, government institutions that need to satisfy some level of compliance where they isolate their networks. So how do you do that? And how do you support your system from running on their network? And probably more importantly, when stuff goes wrong, because it will, how do you debug your problems? Not just how do I get my thing running, but when something fails, how do I give them enough information to debug that system and get that information back to me in a simple way as well. Because honestly, if you make it difficult, people will chuck your stuff away and they'll never trust you again. So that's my personal experience, and that's certainly what I've done in the past. And then time. You can get everything offline if you try hard enough and spend enough money and time. But this is just one part of my job during the day. I just want to deploy your thing. I don't want to learn how it works. I don't want to figure out what the problems are for taking it offline. Please just give me something that works out of the box. There's a huge spectrum of things there. I'm just going to focus on the 3 that I figured have annoyed me the most in my career so far, being on the other side, and hopefully give you some pointers about mostly considering end users, like who's actually going to be running this. So we had end users who were 16-year-olds on, just joined the military. They weren't database administrators. You can't be teaching them this is how you shut OpenShift down. I just want to turn it off and on again. Those kind of questions as well. So I would stress, like, consider your end users as well. Not everyone likes software. Not everyone wants to learn it, and certainly not everyone wants to even consider it's there. They just want to buy a bit of hardware and keep it running. So, architecture, always a problem. I don't really have any good solutions for this one. The main thing I wanted to stress is the same thing again, is I want to evaluate your solution, I want to try your solution, how do I do it quickly and easily? I don't want to have to learn how your entire architecture works to figure out which bits I can chop out, which bits aren't important. Don't put databases in when you don't need databases. That's a lovely one. I hate databases. There's too many databases, and databases are always put in systems that don't need them. If you're going to put a database in, make sure it's a very simple one and we can remove it. A key point there for architecture is make sure you're providing interfaces, make sure you're providing variation points, not giving me more dependencies that I need to install and download, upgrade, maintain, all these other problems. A big issue that we've certainly had in the past, or I've seen in the past, is a lot of cloud native assumes that you scale your hardware to fit whatever the software is that you're running. If you need more compute, you add more compute. If you need to do more stuff, you just scale your hardware up to fit the software needs. A lot of on-prem deployments are the opposite. I've got a fixed amount of hardware. I need to run part of your system, maybe not all of it. How do I do that? How do I scale whatever you give me to fit on my hardware or fit in the requirements that you've given me? Don't assume internet access, that's a big one. This comes into some, particularly around troubleshooting and stuff like that. How do you debug when stuff's gone wrong? Consider when you have a problem, your last customer problem that you had, how would I have solved that if I couldn't get the customer to download something or the customer had to upload something to me? How do I provide that information? One of the worst times of my career has been when we've had to debug a completely non-functional platform, and the vendor kept giving us more dependencies to download and put on that platform to figure out what was wrong. And every time we have to download something, we have to burn it to disk, we have to sheep dip it, we have to then export it, fill in a load of paperwork. It takes multiple days to do that. So if you're drip feeding me like tiny container images, just give me them all at once, or give me a simple way of doing it as well. And the other one, redaction as well. There's loads of support scripts that just collect everything in your cluster and don't give you a nice way to say, what is this thing that I'm going to upload as my support request or something like that. Give me a way to redact some of that information and make me feel confident that you understand my needs. Like, I need to be able to know that the data I'm exporting from my platform isn't compromising our business in any way, or I'm not breaking the Official Secrets Act in any way. If I am, I'm just not going to do it, and I'm not going to use your system. So yeah. And the benefits around having a good architecture, are pretty manifold. It's a lot easier to run things locally. It's a lot easier to stub bits out. If you get rid of databases, then you've got a lot more stateless workloads. It's a lot easier to test them. You don't have to run huge databases just to test simple things out. You get so many other benefits as well. So there's not really a good silver bullet here. I just wanted to touch on the problem. Just consider how you can put variation points in your architecture to have more levers to pull when you need to scale things differently to maybe the traditional use case in the cloud. Dependencies are the other humongous problem. Make it easy to get them, but also make it easy to update them. There's lots of tools that provide you a big tarball of dependencies. That's great, but I don't want to be downloading multi-gigs every single time. Give me differential tars have existed for thousands of years now, so at least give me ways that I can update things easily. I touched on it briefly. Give me a way to get all your dependencies in one go. You must know what they are, and if you don't, then I'm not going to deploy your system. So at least document the way that I can get those things, and I can get them in one go. I don't have to keep drip feeding them and requesting more endpoints and opening it up by security. Filling out paperwork is the bane of my existence in these systems, so don't make me do it more than once. Support mirroring in your configurations. A lot of systems don't. I want to have proxies, container proxies. I want to have container mirrors. I want to have mirrors of anything. Just support it and consider it in your system. It's not just for completely offline environments. There's lots of enterprise environments that need internal mirrors, internal proxies, all this kind of support as well. And you'll also have to deal with enterprise targets. I'm still building CentOS 6 stuff. Still deploying it to large organizations that everyone in this room is using right now. And custom base images. Custom base images is a good one. Almost every secure environment requires a custom base image. You have to use a common base image that's integrated with some security platform or whatever. You can't just go, oh, well, I've just made a scratch image, here you go. Just give me a way to support the custom base image as well. And keep it simple and consistent. If you're giving me tooling to do this, I've got loads of tooling in my network. I've already got an entire pipeline and ways of working and stuff like that. I don't want to have to, squeeze in this whole brand new way of tooling that's bleeding edge. If you can give me tables or some, really simple stuff, that's great, because that just integrates so nicely with any scripting, support, whatever we've already got in there, and people can understand it as well. It's great having this wonderful new tool, but if it makes this sort of arbitrary artifact that you can't really understand, it's not very useful. Try to use existing technology. Not only is it, it's proven, but it works on those older targets as well. So it's always better, and you've always got people in the company who already understand it, and they're more likely to sign off on buying your system if they understand it. And there's also the concerns around, you get a lot of provenance, attestations, SBOMs, all these kind of security artifacts now. How can we get those and use them in our environment? Particularly when we start mirroring containers or changing things, how do we align what we have with what you've given us to make sure those artifacts around provenance and security are there? And then the last dependency that everyone forgets about, licensing. So I had a vendor that required our submarine to connect to their license server every 3 months. We did not purchase that vendor for obvious reasons, because I then asked them, what happens if I can't get a license because I'm underwater? And they said, all functionality is disabled. And it was like, no, that's not great. So consider how you might support licensing. Please don't do the Oracle approach of auditing. But yeah, consider how we can do licensing and configure it. People want to pay for licensing. I'm more than happy to pay for licenses. It's not my money. But how can we properly do it and manage it? And then the other side of the coin that everyone forgets about, documentation. Almost everyone you speak to will, particularly if you've got a large enough budget, and says, I would like to take your thing, but I need to deploy it in some form of isolated environment. Sales will tell you, yes, of course you can do that. And of course you can do it. You just have to figure out how to do it yourself. So it may be possible, but my guiding principle around this was, if it's not documented, it's not supported, I'm not using it. Because it means not only have you not considered my use case, you're not testing my use case. It may break next version. I'm then hamstrung with whatever I've got. So prove to me what you understand what I need. Document as well that you'll work for multiple versions. People aren't going to be upgrading to your latest and greatest all the time. There shouldn't be a need to upgrade. There should be a clear upgrade paths. We're only supporting from like this major version to that major version. Here's a migration tool, whatever. But at least have something in place. And also, when I'm evaluating it, give me an option to provide a complete standalone stack in less than 1 hour. That was always my threshold as well. If it took more time than that, then it's just not going to be a good fit for us. Obviously excluding all downloads, because some of them are massive and takes ages, but having a good way to get a standalone simple stack comes into architecture as well. It makes it easy to test, reuse, and test locally, iterate everything locally. And then documentation side again, debugging and support. How are you going to support those kind of environments? What are you going to do when something goes wrong? Because something will go wrong. People are rubbish at deploying things with instructions, so they'll deploy it wrong. How do you know they've deployed it wrong? These kind of questions as well. Not just failures, but like configuration failures as well. Right, so I've talked about all the problems I've seen. Well, some of the problems I've seen. I've tried not to go into too many tangents. But I just wanted to bring up some examples of good kind of tooling that we've used in the past. So I've used K3S myself. I know it's deployed on various platforms as well that are very isolated. But we've also built products based on it. I worked at startups where we didn't want to support a million different ways to deploy our project on VMs or whatever, so we just wrapped our container up. We only support Kubernetes, and we wrapped it up into K3S with an RPM, job done. Now we just support a Kubernetes deployment and let K3S and their maintainers fix all our problems to some degree. It works really nice. They've got a nice offline images tarball as well that's quite straightforward to use. It can be quite big, but also it works out of the box, and I don't need anything else, so I know it's fine. Trivy. Trivy has been a long time favourite of mine for about 10 years now, maybe more than that. Ever since one time I had to deploy a security scanning system to an offline environment, and all the popular scanning tools at the time required a bloody database. Now, running that database on a single node system was almost impossible. Getting that database downloaded was really difficult. Keeping it updated was really difficult. And in the end, we came across Trivy, and Trivy requires a database, but lets you download it as part of its setup. You can just get it to download, and it will include it locally on its container image if you want to package it up. So that was a much more simple, straightforward approach as well. Pretty well documented, easy to use. I've not had any issues, and I'm pretty stupid, so it should be good for everyone else. A long time ago, back in my defense days, I also worked on Stack in a Box, which was an OpenShift development platform we were supposed to provide for contractors and third parties. So contractors there are people, other companies that we were contracting to do work. A fully working development platform that was identical to our OpenShift runtime platform that was deployed on the various submarines and stuff like that. So there are lots of issues there. The Trivy issue came up in that as well, and I did a talk on that a while back, so I was just linking it there. But that was quite a difficult project at the time. OpenShift didn't support single node deployment. We needed single node deployment, so there was a lot of work with Red Hat as well around some of that. And then there were some very hard requirements on the runtime platform as well, like from power off to minimum safe sonar, less than 2 minutes, those kind of things. So it's quite a tricky thing to do, and I was pretty proud of it in the end, even if maybe it was a bit of a mess of a project halfway through. And then I worked for an observability startup called Calypso, and we made a standalone version of our kind of observability stack, and that was my attempt using Helm charts essentially to provide that kind of configuration around the architecture side, allowing us to support different container registries, being able to configure different components of the system, but also then wrapping it up so I can download all of that and give you an RPM or a deb or whatever just to install it, because that's what a lot of enterprise providers want. They want, I understand VMs, I just want you to give me a VM that I can a package I can just put into Puppet, Chef, Ansible, whatever, and funnel it into my system. I don't want to manage another Kubernetes environment and work with Helm charts and stuff like that. So those are some examples there. Some other approach, so I was doing some research recently to look at some of this stuff. Architecture-wise, particularly around configuration, I'd say the standard approaches are Helm or Customize at the moment. If you're not using those, it's going to be hard for other people to figure out what you're doing. So probably just stick with them if you can. A good reason for it is, you can dump everything to YAML and get the output that way, which fits nicely, not only with GitOps, but also then syncing it across an air gap is quite straightforward because it's just a file. It's not some weird binary or anything like that. I did see microconfig, but I've not really used it, but it looked like an interesting approach. But again, I'd say if you're not using an industry standard, you're making a mistake. So don't make something up. There's a lot of stuff there. When I first started doing the standalone thing we needed to do for Calypso, I ended up realizing that I was basically re-implementing Helm in Bash to try and solve my problems. I was like, why don't I just? We had a Helm chart. Why wasn't I just customizing that and doing that? So sometimes take a little bit of a step back and look at what you got as well. And then, dependencies. You need some way of managing all those dependencies as well. You've got package downloads, you might have some custom scripting, you've got containers, Scopio and Crane are good examples at the moment. I've used Scopio quite a lot. We even use it for like the open source side to promote the container images and stuff like that. It's a pretty good solution, and it's pretty well established and easy, and well documented as well. And then more recently, some other solutions have come up, more fully featured things for taking your entire deployment and running it in a complete offline solution without you having to do any work. That's their goal. It's not quite true, but yeah. Hauler comes from the Rancher folk, and Zarf comes from Defense Unicorns. So I'd not used both of them until I did the demo that hopefully I'll show you in a minute if we don't run out of time. But they're more fully featured solutions and are quite interesting as well. So what is Hauler? At a high level, it's just a glorified tarball maker. Everyone can make a tarball. How do you make it? How do you configure it? What do you do? You know, everyone has their favorite bike shed color for their bash scripts. So it's very much a YAML definition of making a tarball out of lots of different components, and gives you a single thing at the end that you can do. It's pretty good. I've been playing with it the last few days, and it's pretty nice. It works with all the standard container native stuff, but one thing that's pretty good for it is it also works with just random files, like if you just need to provide some package or some specific binary or something like that. Maybe it's not in a container image. Not everyone's always deploying container images. How do you do that? So the demo, I just put K9S on there just as an example, but it lets you pull in random files as well that potentially you need. The downside, I would say, if you go look at the documentation, a lot of the documentation has sections for the things I want to do, and then that just says, oh yeah, we're going to do this in a new release, or please submit some documentation for how to do this. So it's a simple tool, and it makes it consistent, but I'm a little bit concerned with the lack of documentation. How does that work? Although, with the Rancher and K3S stuff, I generally trust it to work. These are open source as well. I've not picked anything that's not open source. So you can go validate it as well. So yeah, I'll show you a quick demo of that in a bit. But essentially, Hauler makes you a tarball, you transfer it, and then you can push it into whatever system you need. You still need to do the deployment on the other side, though, which is where Zarf comes in, which is a little bit different and solves a slightly different problem, I think. Zarf's goal is to take one cluster that you've got running online and be able to completely deploy it offline as well with nothing else. The documentation is really good. I encourage someone to go look at it as an example just of how to write documentation. But they've got great examples. It's a really good thing for an offline demo. Hopefully I'll show you in a minute. It's distro agnostic, they claim. So by distro they mean Kubernetes versions there. So it should work on any kind of certified Kubernetes, but again, proof's in the pudding. You'll probably find a Kubernetes distribution that's missing some standard component that it will fail on, but yeah, it seems to work for me. You can use it for built-in mirroring, so you can just run it on one cluster and mirror somewhere else. So good for a kind of a failover with like AWS or something like that. The downside I can kind of see there is they don't really support non-container artifacts. So they'll support Helm charts, they'll support container images, anything that's in an OCI registry. So potentially, if you want to do that, you could push anything you need into an OCI registry and mirror it that way. They've also got they'll do Git mirroring as well, which is quite useful. I know yesterday there were concerns because AWS was down, all the documentation was down for like Confluence and stuff like that as well, because people couldn't log in. So a lot of run books and stuff like that might not be available, so it might be useful to mirror that. They've also got an injector approach so they take a cluster that has nothing in it and then they seed it with a registry. But how do you push a registry image to something that doesn't have a registry? So they've got an interesting approach of reconstructing a registry image from config map chunks and bootstrapping it into the cluster. I'm not sure I'd ever use that in production because you have to run a cluster at that point. Just run a registry as well. It's quite straightforward, but it was quite good for the offline demos and stuff. You just spin up a cluster and everything's ready to go. You don't need to start pushing images to custom registries. But it's worth having a look at. It's quite interesting. So demo time. So I'm going to do a demo. Everything's up on the Git repo. That's where I'm running it from. It's just the observability stack. So kube, prom, Kuprom stack, I think it is, I can't remember what it's called, with a Fluent Bit deployment as well. So I'll show you what Hauler does, and then what Xarf does as well. I'll start with Xarf because it's a bit more interesting, and then because Hauler just makes the tarball. So yeah, cheers. So we've got 5 minutes, hopefully I can do the demo. Right, so I've spun up a cluster. It's just a kind cluster. Earlier on today, just before in the previous one, I created my Xarf package. So that's defined by, again, like everything good, defined by YAML that just says all the components that you want to do. Well, let's just go show it in here because we're offline. So it's just some, can everyone see that by the way? Yeah. All the different things you want to get. So I've mirrored the Git repos there just to show you. And then, the good thing here is you can see I've got 2 different Fluent Bit deployments there. I've got one that I run as a daemon set, and then I've got, I don't know why it's indented slightly different. Oh yeah, there we go, daemon set to forward to an aggregator. So Hauler will just collect everything you need. Xarf will take your deployments and mirror them. So that's why it's a slightly different approach. And then, so earlier on today, downloaded all that. You get a little ZST package here. It's got everything in it. That's just the tarball. You can open it up and have a look. And then I can deploy it into the cluster. Let me just get the commands. So first of all, there's a little bit of Xarf in it. And the main thing here is just initializing the Git server to show the mirrored stuff. So hopefully we'll see it in a minute. Oh, let me turn the Wi-Fi off just to prove that we're offline. So the idea here is it will deploy everything for the Xarf kind of setup, which includes this weird Docker registry approach of reconstructing it. If it picks it up quickly enough, you'll see one registry then another because it bootstraps one and then provides the other. So we've done that. Now we need to start pushing the things. So it hosted a registry, and then it pushed the registry image to that registry to then run the actual registry, which then hosts all the other stuff. So it's, and then there's some mutating webhooks to deal with making sure your things are all pulling from the right registry and stuff like that. And then we've got git t for the internal Git server. And I'll just go grab the other command, which is... So Xarf's really nice for if you want to do an offline demo, really good, because you can also get it to deploy K3s for you from scratch. So it seems a nice way of making a single, just having a tarball and you know it will run even if the Wi-Fi's crap or whatever. So now we're deploying git t. There we go. So everything should be set up in the cluster, ready to go. There's git t down the bottom. So now I'll deploy the package that we made before, which we can kind of see here. Xarf. Might take a while because it's quite large. But it's basically just a load of SBOMs, containers, and Helm deployments. So we push all these, we run up the stack, and you should have a completely functional solution after that. So we don't need to we don't need to deploy anything, we don't need to do anything else. It's just going. Whereas Hauler's quite the opposite, which is like Hauler just grabs everything you need, and then it's up to you to deploy it on the other side. Which, to be honest, is probably what you're more likely doing. Xarf seems quite nice though for doing demos and things like that. Or maybe for people who don't really understand Kubernetes or don't want to get involved with it as well. Right, so now it's installing a Helm chart, and remember I've turned Wi-Fi off, so we haven't got anything. So we're definitely offline. Come on. I probably should have picked a lighter weight Helm chart. But it definitely worked earlier. There we go. Everything starts spinning up. So again, I've not had to do anything. I've just said deploy this tarball, and off it goes and replicates the same stuff you've configured in your YAML file onto your offline solution. So it might be quite useful as well if you want to package it up into your own package and stuff like that. And you can remove the Xarf stuff afterwards to Yeah, I've got all that there. So yeah, we get a Prometheus stack. Now we're going to now deploy Fluent bit, and then if we have time, we could look at the dashboard and stuff like that. But we'll probably run out of time for that. In fact, should we move to questions while it's doing this? If anyone has any.
Any questions, or is everyone just hungry?
Yeah.
This gentleman at the back.
Okay, so it's just a quick question about the registries. So you're creating a table from the one environment, putting it in the air-gapped environment, and then you need to keep running the sub-registry in order if there are like worker reboots or something, if the registry is deleted, then you need to redeploy the sub-registry in order that the worker can move it.
No. So you can. Again, I wouldn't not use Zarf personally to deploy an offline environment, just because I would want more control over what's going on. But you can use it to push to your own registry and use that. And you can set the registry to be HA if you really want, and in cluster as well and stuff like that. I'd probably use the hauler approach, which is more like, here's all the images, and again, that can push them to wherever you want to push them to. But hauler is more about giving you the artifacts, and then it's your responsibility to deploy them, whereas Zarf seems to do the whole lot for you, which is nice and like for offline demos, but maybe isn't what you want in a completely offline solution. Yeah. Probably should give a shout out to the Manchester meetup as well. I help host, so if anyone's in Manchester and wants to come talk about cloud native stuff as well, we've got one in November, and it'd be good to see more people, particularly if people want to talk, particularly if people want to sponsor or host. We need those as well. So yeah. Okay.
Any more questions? Oh, here we go. Tim.
Hello. It's handy to push one thing over the air gap and then take it apart and sort of inspect what's there and see if you're happy. How much should we think of that one thing as an artifact?
Yeah, and how do you add provenance and security to that thing as well? I'd also set caution as well. Yeah, it's great to have one thing, but if you're going to do something like differential uploads or something like, it might be better to make it a bit more granular. For me, it's more about having one process and I can do it in one go, rather than maybe I could have like 1,000 tarbles, I don't mind, as long as I can do all of them in one go and deliver it. And I notice in both of these tools as well, they start generating SBOMs for the actual components they're putting in, and then you could generate an SBOM and a provenance attestation for the overall artifact as well, I guess. And you certainly would need that. It's like you can't do, I download this thing off the internet, here you go. Yeah, it's fine. So yeah. I skipped over security because it was hard. So yeah. Yeah, everything's running.
I'm curious about the training and the expertise. So taking, for example, you deploy a system on a submarine, would that then require a Kubernetes administrator to run that, or is that a case of?
So So I think this comes into considering your end users. No, they don't want that. They don't care what they're doing, what the software is. They bought a submarine. The people on board are pressing buttons on the submarine and fighting and doing whatever they need to do. A lot of them don't want to be database administrators, OpenStack administrators. So you'll find in those cases a lot of the requirements are like, I can just turn it off and on again and it will work. I don't need to consider Kubernetes in any way. It's more about, I've got a UI that I've been trained to use and this deploys things for me and stuff like that. So it's the people on the boat generally aren't given access to like infrastructure, because they'll start hosting game servers and other things as well. So it's very much for the engineers just to use that. So the people on the boat, again, consider your end users. We provide UIs, UX approaches for, I need to run this sonar system and it's made up of these components. So you give them buttons, start, stop, those kind of quite straightforward stuff. But also, how do I deal with self-healing? How do I tell you when stuff's gone wrong in a good way? Not just like a million alerts that SREs just ignore and stuff like that. They very much, if something's important, tell me about it. If it's not important, what are you doing? And they have very strong requirements about turning things off and minimum boot times and stuff like that. So you have to consider other approaches as well. Like the minimum boot times is impossible to meet with Kubernetes clusters generally. So we ended up doing stuff where we'd run a fixed compose stack or something like that to give you enough software to keep running, but then bring everything else up in the background and switch back over to it. So you could run degraded, but at least you could see where you're going. It's kind of, end user concerns. It's like, not everyone's database administrator, not everyone's Kubernetes administrator, and they certainly don't want to be. So I don't think I answered your question. I just said, we don't do that,
Broadly answered. Thank you.
Yeah, that's right.
Okay, I think we've got time for one more. If there is one.
Feel free to find me afterwards and I can give you more anecdotes and complaints.
Wonderful. In that case, let's go for some lunch. But thank you again to Patrick.